Let's take a look at this RSTP sync process in action with a walkthrough. All this is a very simple series of handshakes between switches, and it's carried out until all switches in the network are synchronized. We're going to do this walkthrough. Like I said, there's a lot going on at one point, so don't let it overwhelm you. And that's why we've broken it down here, because at this point, at the very beginning, switch 1 is the root, switch 2 is connected to switch 1, and also a PC, and then switch 3 is downstream from switch 2. There's something very godfatherish about this, or old school mobster. The root is saying, hey, I got a proposal for you. Well, the proposal is, I'm the root. And switch 2 gets that superior BPDU, the proposal, and would like to agree to said proposal. It might get hurt otherwise, but not so fast. It can't agree to it immediately, because switch 2 has to sync itself. And in order for switch 2 to consider itself synced, all ports on 2 must either be discarding or an edge port. And now you immediately say, well, I know why that PC's hanging up there, because we know that's an edge port. What's the command to configure an RSTP edge port? Spanning tree port fast. That's an edge port. Now switch 2 actually has to put the port leading to switch 3 into discarding mode. It's really cutting itself off from all other communication for a while, because that would be true no matter how many other switches were there. We just say, okay, I'm busy, I can't talk to you right now, I got to put you in discarding mode. Now, a lot of things will then happen here all at once, or almost at once. Switch 2, of course, it's going to move its root port into forwarding. And at that point, switch 2 replies to the proposal with an agreement, and then sends a proposal of its own out any non-edge port that was just placed in a discarding state. So there's a lot going on here at one time, and then switch 3 is going to say, okay, let me do the self-synchronization thing too, and then I'll get back to you. So this process that we've just seen between 1 and 2, where you have the proposal, and then you have the self-synchronization, and then you have the agreement, that's going to happen on every switch downstream from switch 2 now. And then all the switches that are downstream from all the switches that just did that, it just keeps going and going. And again, I call it the ripple effect. It's very powerful, because switch 2 here is agreeing with 1 while almost simultaneously sending a proposal to 3 and any other downstream switches it's connected to. Then switch 3 goes through the same process, and it just keeps going and going and going. Again, it's just like dropping a pebble in water. You see one little wave, and then you see more, and then you see more, and it keeps going out. And where that, stops going out, when the energy stops pushing the water out, in this case, with RSTP synchronization, it's not going to stop until every switch in the network is synced up. It's very, very cool stuff. Now, the question haunting networks everywhere. What could this be? It could be, does RSTP play well with spanning tree protocol? That's really the number one question for us practically, on a practical basis as network admins, because if we've got 500 switches and we want to migrate to RSTP, maybe we can do all 500 at one time, maybe we can't. Well, if a switch is running RSTP and needs to communicate with switches using both STP and RSTP, it's the version number in the BPDU that tells the switch how to handle things. And what we're going to have in our particular network, we're going to configure this in just a moment, run a show command or two, is switch 3 is going to be running RSTP. I haven't configured that on there yet. Switch 4 already is running RSTP, and switch 2, which is also trunking with switch 3, is running spanning tree protocol, good old-fashioned STP. The BPDU version number will be different in the BPDUs coming from switch 2 and from switch 4, and it's that BPDU version number that's the tip-off to switch 3 and says, okay, I know how to handle this communication from switch 2, it's STP. Oh, well, this BPDU coming in from switch 4, that's version 2, so I know it's RSTP. So let's go ahead and bring that up, and I've got our show spanning VLAN 1 command to start with. And something we really didn't concentrate on earlier in this output, and you're thinking, really, there's something we didn't concentrate on earlier in this output? Are you kidding me? But there was, and it was this line right here under VLAN 1. Spanning tree enabled protocol IEEE. that means we're running STP. That's where we are right now. So let's go over to switch 4, and I'll just show you that real quick. Show spanning VLAN 1, and you could see spanning tree enabled protocol RSTP. So that's where you can look for that particular value. So let's go ahead and go back to 7 here. And, excuse me, to switch 3 on connection 7. Spanning tree, boy, we've looked at almost all of these, not all of them. And right now we're going to look at mode for the first time. And there's multiple spanning tree, which we're going to discuss briefly in the next section. PVST, per VLAN spanning tree, which is what we've been running. And now we've got rapid PVST, and that's what we're going to run, rapid per VLAN spanning tree. And so far, that's it. And I wanted to run that live because I wanted you to see, you know, there's nothing that's going to go down here, we hope. We haven't verified yet, but we will in a moment. And let's just do a quick show spanning VLAN 1. And we're still in learning mode in our connection to switch 2. That's fast O/11. But notice that now we are indeed running RSTP. So let's give that another moment, and here we go. So switch 3 is running running rapid spanning tree protocol, and now it's in learning stage to the port leading to switch 2. But note the difference here at the edge. We've got PTP and then PTP peer STP, and I don't mean like an edge port, I just meant at the edge of the output. Let's run show spanning VLAN 1 one more time. And now we are up and running. But the one thing, a couple things here I wanted to point out. The first one being, of course, spanning tree enabled protocol RSTP. But you can also tell what the other partner on the other end of the trunk is running by looking at this when you've got RSTP enabled. When you see just PTP, that means, of course, point-to-point connection. And that is indicating, since nothing else is said after that, that particular partner is running rapid spanning tree protocol. When you see P2P peer and then STP after it, that means that the peer in that neighbor relationship on the other end of that trunk is running the spanning tree protocol 802.1d, just plain old STP. So really that's all there is to enabling it. We've gone over the port types, the port stages. One other thing that I did want to point out as far as these go, I believe it's an interface command. Yep. It is very, very, very rare that you are ever going to have to change the actual link type of an interface in spanning tree. But if for some reason you have to, and I think in a lab once, the reason I show this, it happened to me once, I want you to know about it. An interface should have been showing as point-to-point, but wasn't because it was at full duplex. You can hard code that link type. And shared, of course, would be a half duplex point-to-point. Consider the interface as point-to-point. If it's a full duplex interface, which these all were, RSTP should know that and should see it. But just in case it doesn't, you can indeed hard code that link type. That is it for the rapid spanning tree protocol. We're going to spend a little bit of time with MST. I don't mean to make it sound unimportant, but we are going to hit the theory of that in the next video and then move on. I'll see you there.